All right there, guys. Well, first of all, I want to congratulate you for getting all the way to this video. If you're watching this video, that means that you probably have the other 7 things done, and this is the final thing you're after in order to be a legitimate A student in Unit 4, which we call right triangle trigonometry. I'm excited to be bringing you this video, and hopefully this is the last piece of the puzzle that you're looking for. When we talk about applications of SOHCAHTOA, what we're going to talk about is a lot of times we're talking story problems. And within story problems, there are a couple of times where we're actually going to see words that show up a lot of times in a story problem. And it's angle of elevation or angle of depression. And I just want to make sure that I kind of give you an idea of what those words mean. All right, if you are thinking about an elevator, and I know an elevator takes you up and down, but when I think about to elevate, I always think, a basketball player runs and jumps and elevates to the rim. I always think elevation, I always think going up. So when I think of angle of elevation, the angle of elevation, if you take a look at the picture over here of the tree, the guy's eyesight, when he looks straight at the tree, right, it's called the horizontal line. The line of sight is the line at which his eyes are actually looking. And the angle that's created between those two lines is called the angle of elevation. And notice that it goes up. Right, so an angle between the line of sight and the horizontal line when looking up is called the angle of elevation. Well, very similarly, if you are looking down, and I always think like when you are sad and you're down, you are depressed, right? Same kind of thing. If I am looking down, then it is the angle from the horizontal. So you see the owl here is looking directly horizontal. The line of sight as he looks down here at the squirrel. The angle of depression is the angle that comes down. So the angle of elevation is always equal to the angle of elevation. The angle of elevation is always equal to the angle of depression. And if you wonder about that, take a look at 2 parallel lines. So if I have a line of sight up here and down here, and I look down, my angle of depression or my angle of elevation, those are alternate interior angles, and we know from Unit 2 that alternate interior angles are congruent. So I know that angle of elevation and angle of depression would need to be the same. So taking a look at the first example, this is just making sure that we can name the angles of elevation or depression, and then we'll get into some real-world problems. So name the angles of elevation. So if I'm standing down at the house on the ground, looking up, angle 2 is an angle of elevation. If I'm in the hot air balloon, I'm looking up at the bird, angle 1 is an angle of elevation. If the bird is looking down at the hot air balloon, angle 3 is an angle of depression. Angle 4 is the balloon people are looking down at the house, so angle 4 is an angle of depression. And then it wants the pairs that would be congruent. So if I take a look at the house and the hot air balloon, angle 2 is congruent to angle 4. If I look at the balloon and the bird, angle 3 is congruent to angle 1. So that's angle of depression and angle of elevation. So let's take a look at an actual problem. Here's a real-world problem. And it says the top of a signal tower is 120 meters above sea level. The angle of depression from the top of the tower to a passing ship is 25 degrees. So I'm going to first draw that angle. So I'm going to take my horizontal line. All right, that's my horizontal line of sight, or my horizontal line. The line of sight, all right, I already see that, is right here. So the angle of depression is this angle up here. The angle of depression is 25 degrees. And it wants to know how many meters from the foot of the tower is the ship. So how far is the ship right here from the tower? Well, my triangle that I'm going to look at is actually right here. And if my angle of depression, I'm going to move this down here, my angle of depression is 25 degrees, so my angle of elevation down here would also be 25 degrees. And now it's just a SOHCAHTOA problem. So first thing I like to do in SOHCAHTOA is label my HOA. So my 90-degree angle, so that makes this my hypotenuse. 25 degrees, 120 is my opposite, and X down here is my adjacent. So in this case, which one of SOHCAHTOA would I use? I'm not using the H at all. I have O is 120 and the A is X. So O and A is tangent. So I will do tangent of the angle will equal opposite over adjacent. Right, that's the TOA part of SOHCAHTOA. So what is my angle measure? Well, the tangent of the angle is 25 is equal to the opposite side 120 over X. And you've probably gotten pretty good at this now. When X is down, I divide. So, or I can think about switching places with my X and my tangent. So X will move over here. My 120 is still 120, and the tangent of 25 goes on the bottom. So I just need to put in my calculator 120 divided by the tangent of 25. So 120 divided by the tangent of 25. Let me double check my mode. I am in degrees. So go ahead and hit enter. So 257.3. 257.3 is answer choice B. 257.3 meters. So that's just using a word problem and then turning it into SOHCAHTOA. All right, as I go to the back, here's an example. Indirect measurement says Kyle is at the end of a pier 30 feet above the ocean. So now we're going to test my drawing. So Kyle is 30 feet above the ocean. All right, so this is the ocean. Kyle is on a pier way up here, 30 feet above the ocean. Now I'm going to assume that he is at a right angle. This is where Kyle is standing. It says his eye level is 3 feet above the pier. So Kyle's eyes are another 3 feet up. And he's using binoculars to watch a whale surface. So down here we have a whale. So Kyle is looking straight down here. It says if the angle of depression, so angle of depression coming down, angle of depression is 20 degrees. How far is the whale from Kyle's binoculars? So the whale to his binoculars would be this distance right here. So I want to turn this into a right triangle. I kind of have this little really well-drawn picture. I hope none of you are friends with Mr. Bibler. Don't tell him on me. But I have a right triangle. So let me bring in a right triangle. All right. And I'm going to flip this thing. All right, so something kind of like this. So I want to find this X distance. Now I know that Kyle is standing, his eyes are 3 feet above a 30-foot pier, so this side is actually 33 feet. If the angle of depression is 20, then the angle of elevation is 20, which makes this angle down here 20 degrees. So now I think I can go SOHCAHTOA. So the first thing I want to do is label my HOA, so across from the hypotenuse first is H. opposite side of the angle and adjacent side. So in this case, 33 is opposite, x is hypotenuse, so I want to do the sine. The sine of the angle is equal to the opposite over the hypotenuse in SOHCAHTOA. So the sine of 20 degrees is equal to the opposite side, which is 33, divided by the hypotenuse, which is x. This is another problem where the variable's down, so I divide. Or I can kind of do my little switcheroo here. So x is equal to 33 divided by the sine of 20. So 33 divided by the sine of 20. 33 divided by the sine of 20 is 96.5. So x is equal to 96.5, and I'm measuring this in what distance? Feet. That means that whale from Kyle's eyes, 96.5 feet. Things that you really need to be careful of, make sure that when you are labeling your, when you're drawing your pictures, hopefully you're a better artist than I am, but make sure that you are first just drawing your picture to kind of get an idea and then turn it into a nice looking triangle. Sometimes it makes it a little bit easier to do that. All right, one last problem. This is a challenge problem. And it's just, the only reason it's a challenge is because you have to do this a couple of different times. So it says Olivia is in a lighthouse on a cliff. She observes two sailboats due east of the lighthouse. The angles of depression to the boats are 33 and 57. Find the distance between the two sailboats to the nearest foot. So let me show you the distance I want is this distance from A to B. And in order to find that, I'm actually going to find the distance from D to A first. I want to find this distance first. Then I'm going to find the distance from D all the way over to B. And then I'll subtract those two distances. That will leave me that black line distance. So let's find that red line distance first. As I take a look, I can turn this into a red triangle. That's pretty easy. Whoa. I say it looked easy, didn't it? There and there. So my angle of depression to the red line I can see is right here. It's 57 degrees. So that means this angle down here is 57 degrees. And doing SOHCAHTOA, this left side, ooh, this is tricky. The cliff is 110 plus another 85. This whole side over here is 195, and it is the opposite side. I want to find x down here at the bottom, which is the adjacent side. So if I have opposite and adjacent, then I will be doing tangent. The tangent of the angle, in this case 57, is equal to the opposite side, 195, over the adjacent side, which is what I'm looking for. Variables on the bottom, so switch them. So x equals 195 divided by the tangent of 57. So 195 divided by the tangent of 57 degrees is 126.6. So 126.6. All right, so I'm going to go in and I'm going to erase all that red stuff. All done with all the red. Okay, I know this. This distance right here is 126.6. That is the distance from the cliff over to the sailboat A. From D to A is 126.6. All right, now the green sailboat. All right. From D over here to B is what I'm trying to find. I'm going to call that x. The height up the cliff is still 195. Distance down here. The angle of depression for the green line is right here. It's 33 degrees, so this is 33. Well, 195 is still opposite, x is still the adjacent. So again, I'm going to use the tangent. But this time it's the tangent of 33 degrees. And that's going to equal the opposite, 195, over the adjacent, x. So that means x is going to equal 195 divided by the tangent of 33. 195 divided by the tangent of 33 degrees is 300.3. 300.3. So this big distance. So let me pull some of this stuff out here, clean it up a little bit. All right, it is 126.6 from D to A. This distance right here, all the way across, is 300.3. So if I want to find the distance from A to B, then I need to know that 126.6 plus that distance from A to B has to equal 300.3. Those two little pieces have to add up to the big piece because that is the segment addition postulate. So this distance AB is pretty easy to find. AB is just going to be found by doing 300.3 and subtracting 126.6. So let's go to the calculator one last time. 300.3 minus 126.6 is a distance of 173.7. So AB is 173.7 feet. So that is a challenging problem. Right? It was called a challenge for a reason. And the only challenge really was to find two different distances and then subtract the two away from one another. So I hope this video helps. Make sure you're getting a lot of practice. And if you have any questions, as always, don't hesitate to ask. See you guys.